Hello again. Welcome to part 3 of our simplifying algebraic expressions. And right now we're going to start on multiplication and division property of equality. Division properties of equality. Alright, so just like our addition and subtraction, we are going to start by letting the value, let's say 5 equals 5. Okay, so no one can deny that that is a true statement. Okay, so what if we decide we're going to multiply both sides by 8? So multiply both sides by 8. Okay, so if we did that, we'd end up with 8 times 5 equals 5 times 8, which would give us 40 equals 40, which no one can deny is another true statement. Okay, so what if we get that true statement and we divide both sides by 10? Divide both sides by 10. Okay, so if we did that, we would end up with 40 divided by 10 equals 40 divided by 10. So we know 40 divided by 10 is 4, so that gives us 4 equals 4, which again is a true statement. Alright, so that is the basic idea of our multiplication and division properties. So multiplication and division property of equality. Oops, not a space there. There we go. So instead of just picking a 5, let's say if we let A, B, and C represent any real number. Okay, now let's say we have the stipulation that A is equal to B. Then if we multiply both sides by the same value, then they would still be equal. And same thing with division. We still have A equals B. If we divide both sides by the same value, it will still be equal. Okay, so let's get started on a few examples. Alright, so let's say for our first example, we wanted to solve 2x equals 16. Okay, so to solve that one, I'm going to go ahead and rewrite it. we have to divide both sides by the coefficient, which is 2. Now, you always, the goal here is to get the x by itself. So in order to do that, you have to divide both sides by whatever the coefficient is. Okay, so we're going to divide, I'll just use the division symbol, both sides by 2. Okay, so if we divide this side by 2 and this side by 2, anything divided by itself is just 1. So 2 divided by 2 is 1. Okay, so you have 1 times x, which is just x. So you have x equals 16 divided by 2, which is 8. Okay, so if you plug in x and replace it with 8, you have 2 times 8 equals 16, which is true. Alright, so let's do another example. Let's say if we wanted to solve 27x equals 5. And I want you to press pause and try to do this one on your own first. Alright, so I'm assuming you've already pressed pause and you're done working, so we're going to go ahead and work this one out. So 27x equals 5. So here, you have a coefficient of 27, so that's what we're going to divide both sides by. So again, we're going to divide both sides by the coefficient in this case, which is 27. Anything divided by itself is just 1. So you have x equals 5 over 27. So if you replace x with 5 over 27, you will get 27 over 20. So 27 will cancel out. You get 5 equals 5, which would be true. Okay, so let's say, for example, we wanted to solve y over 3 equals 9. Okay. Now, just a quick note. You may have either y over 3 equals 9, or it can also be written as 1/3 y equals 9. Okay, so both of these are the exact same problem. So you would solve them both the same way. Okay, so I'm just going to go ahead and rewrite that up a little bit. So you have y over 3 equals 9. Remember up here, we have multiplication, so we have to do the opposite and divide. Here, we have division, so we have to do the opposite and multiply. Okay, so you're always going to do the opposite to get the variable by itself. So we're going to multiply both sides by whatever the denominator is. Okay, so we're going to multiply both sides by the denominator. And in this case, that denominator is 3. Okay, so that would actually give us 3 times y over 3 equals 9 times 3. Okay, and these two 3's will cancel each other out. And here's y, in case you were wondering. If you have 3 times y over 3, that's the same as saying 3 over 1 times y over 3, because 3 is just 3 over 1. Okay, so you can just multiply 3 times y over 1 times 3, or you can flip it to 3 times 1. Anything divided by itself is just 1. So you have y over 1, which is just y. Remember, anything divided by 1 is just that value. Okay, but you don't have to go through all of that, because you can just cancel it out right here. Move that up a little bit. Okay, so now you have 1 times y, which is just y, equals 9 times 3, which is 27. Okay, so if you plug in 27, 27 divided by 3 is 9, so we know that that is correct. Alright, so let's go to our next example. Move that down just a little bit. There we go. Okay, so let's say for this example, we wanted to solve 2x equals 16. Okay. So we do the, oh, sorry about that. Went over my list of examples and we wrote the wrong one. Let's say if we want to solve x over 7 equals 5. Sorry about that little mix up there. Okay, so you can go ahead and press pause and give that one a try. Okay, so assuming you've already pressed pause, you're done working, we're going to go ahead and rewrite it. X over 7 equals 5. So again, we're going to multiply both sides by whatever the denominator is, because we want to get that x by itself. So you're going to multiply both sides by the denominator, which in this case is 7. Okay, so that will give us 7 times x over 7 equals 5 times 7. Okay, and again, these two are going to cancel each other out. So you just have x equals 5 times 7, or x equals 35. Okay, so we're going to do one more example. We're going to move that up a little bit. So what if we want to solve 4 times 2x minus 3 plus 7 equals 3x plus 5? Okay. So if you remember back in the addition subtraction properties video, we had steps whenever you had a linear equation with parentheses. So we're going to go ahead and follow those steps. Remember, your first step is to use the distributive property to get rid of those parentheses. That's step number 1. So distributive property, that's your first step. So we're going to go ahead and just rewrite this. So 4 times 2x minus 3 plus 7 equals 3x plus 5. We're going to go ahead and distribute that 4. Okay, so 4 times 2x, 4 times 2 is 8, so 4 times 2x is 8x. 4 times negative 3 is negative 12 plus 7 equals 3x plus 5. Okay, so your second step, if you remember, is to combine all like terms that are on the same side of the equal sign. So we'll just call that combine, the combine step. So the only thing that can be combined is the negative 12 plus 7. We know negative 12 plus 7 is equal to negative 5. So that gives us 8x minus 5 equals 3x plus 5. Okay, which brings us to our third step. We're going to move all variable terms to one side and all non-variable terms to the other side. So 8x and 3x are our variable terms, and minus 5 and plus 5 are our non-variable terms. So we're going to move all the x terms to the left and all the non-variable terms to the right. You can do it the other way if you like. You'll still get the same answer. So if you wanted to move all the x terms to the right, we could do that also. But I'm just moving it to the left because it's just my personal preference, at least for this problem. So move terms. Okay, so we can go ahead and subtract 3x from both sides. 3x minus 3x is 0, so you can go ahead and cross that out because that disappears. So you have 8x minus 3x, which is 5x. So 8x minus 3x is 5x. So we have 5x minus 5, because that minus 5 didn't go anywhere yet, equals, that 3x canceled out, so we don't write that, equals 5. Okay, so right now, our goal is to get this 5x by itself. Okay, so we can't solve for x till we get just the x term by itself, which means we have to get rid of that minus 5. Okay, so whenever we have a minus 5, we get rid of it by adding 5 to both sides. Minus 5 plus 5 is 0, so that disappears. And we are left with 5x equals 5 plus 5, which is 10. Go ahead and divide both sides by 5 using the division property. Divide by 5. Anything divided by itself is 1. So that gives us x equals 10 divided by 5, which is 2. So if you plug 2 into that original problem, you will see that it will be a true equation. Okay, so hopefully this made sense, and I will see you on the next video.